Alrighty, maybe I think I've got things set up on my end. If some folks can let me know if they can see and hear me, that would be appreciated. It's about 10 till, and we can do some shout outs and get started. Does everything sound good? I've got a little bit of feedback on something I got to figure out here. Looks like folks can hear me okay, so that's good. Let's see. Okay, I think I got that figured out. Let's All right. Sorry about the pause there, team. Had like a double feedback thing going on in my headset and realized I had two windows of my YouTube channel open, so it was very distracting. A little bit of a delay there. So, well, good morning if you're here in the Mountain West of the U.S., or good afternoon or good evening. We'll get started here in about 8 minutes. Appreciate, as always, having our moderators on here, Susan Helmer and Amanda Joe, who goes by Mandy Joe on there. Lisa, I don't know if Lisa's on or not. She's in New Zealand, so if it might be a weird, wonky time for her to be on. So, and of course, we'll give a shout out to the Nightbot, the automated moderator who helps out our real folks there. So, wherever you're tuning in from, appreciate you joining us this morning. The quick announcement, and I tried to change the video description and the thumbnails quickly as I could, is we won't be able to do the drone flight today due to some technical issues that Nature I was having, but we'll reschedule that as soon as we can. So, sorry about that announcement and being able, or having to kind of switch on you a little bit there, but I wanted to still do the live stream nonetheless, and I think we'll still have some good information, some nice discussion. We'll of course wrap up with Q&A. So a couple shout outs to folks that are joining us. Let me go up back to the top. We have Mary from Maryland, Irene from Germany, Otter Silver from Texas, Debbie from Olympia. We got Colorado in the house, Kay from Dorset, UK, where it's wet again. Pinball from Manchester, UK. Let's see, other folks we have here. Elizabeth from sunny Scotland. Must be sunny in the north of the UK. Carl Sim from Quebec. Elaine Jones from Tucson, Arizona. Marion from South Africa. Welcome. Carolyn from New York City. STO from France. Welcome. Let's see. Other folks we have here. Francine from BC, Canada. Arwen from Lancashire, UK. I'm probably still mispronouncing that. I apologize. Tanya from Finland. Anna from Finland. Good job, Finland. Lynn from Eagle, Idaho. We got Holland here. Yeah, if you're going to ask a question, Susan and Mandy Joe have that all figured out, and there's some protocol and procedures that are listed there in the live chat, so just make sure you follow those so they can give you the correct information how to do that. Yvonne from Scottish Highlands. Wolfgang from Germany. Petrolhead from Australia. Some of your little handles are just so fun. I feel boring with Shawn Willsey. I should have come up with something more fun back in the day. Marguerite from Norway. Uh, Mama on Doggy from London, UK. And a bunch of people telling me I was 5 by 5. Thank you. Steffi from Germany. Del Claria Astro from Stockholm. Barry from Manchester. Okay, Kay from Dorset, UK. Renate from Rotterdam. Lynn from Santa Barbara. Pinball from Manchester. Mike from Boulder. Sarah from Northwest Ontario. Peter from Sweden. Scandinavia is representing today. Well done, team. Paul P. from Austria. Geo Zach from New York. Andrea from Florida. Esconville from Indiana. Dear Colette from the Western Isles. Yeah, everyone's just being very friendly and chipper. Good job. That's the way it should work. Debbie and Glenn from Winnipeg, Manitoba. Johan from Gotland, Sweden. Laura from Connecticut. Who else we got here? Okay. Ken from Western Colorado. Rod's here, says I sound good. Jackie Nature Lover from Northern Kentucky. Lorna from Bryan, Texas. Lee, Chicago. El Noswicks from Monterey Bay. Beautiful California coast. Kat Mancui from Lodgepole, Alberta. Nida from Atlanta. Oh, and then it jumped down again. Let's see. Oh boy, and then there's a whole bunch here. So I'm going to fail miserably as I always do. France, Wales, Slovakia, Lucas. That's awesome. Noreen from Southern Illinois. Anne from South Germany. BL4KL from Paris. Mary from Bucks County, Pennsylvania. Bjorn de Baker from Holland. Charlotte from the cold but sunny Peak District. Ray from Ely, Minnesota. Bex from London, Ontario. Jamie from Norfolk. Robin of Buffaloes. Rising Sun from Santa Lucia. Very fun. Let's see, I'll butcher this name, I apologize. Sverre from Keflavik, Iceland. Shelley from the UK. Kaz from Lancashire, UK. Heike from North Germany. Cranky Auntie Linda. I hope you're not cranky today, Auntie Linda, from Loveland, Colorado. And she's saying good morning with an exclamation point, so I don't think she's cranky. I think she's just doing fine. Sunny Isle of Skye. Lucine from Edinburgh, Scotland. Lorraine from Kingston, Ontario. Andrea from Tenerife, Canary Islands. Awesome. Pavel from the Czech Republic. Frey from Denmark. Claire from Ontario. Islanders of Jersey. Wet and windy here also, says Joe. Tess from a rainy Sweden. Bergen, Norway. Kaz from Sydney, Australia. G'day. Francis from Winterville, Georgia. Sean from Rosita, Colorado. Egg Bumble from New Hampshire. Gordon from Austria, Vienna. I'll be there in a couple weeks, about a month. Christina from Finland. Lars from Sweden. Bart from Netherlands. Dave from Dubai. Rod says good morning from Ottawa. Matt HJSPW, whoa, that's a tough one, from the Netherlands. Kelly from Wisconsin. Little John from Germany. Gary from Ridgecrest, California. Tina from Keflavik. And AJ from Blackwater, England. Susan from Central Minnesota. Do another minute of these and then we'll get started. Thanks again for joining me, everyone. I really appreciate it. Thanks for rolling with the punches here. We were hoping to do a drone flight with Nature Eye, but they had some technical issues, so it happens. It's okay. Make the best of it, right? Bunkinator from sunny Scotland. Al from Austin, Texas. Susan from Ontario, Canada. And I'm falling way behind on this. Ricardo from Portugal. David, Portland. James from Virginia. Old guy from Berkeley. And Jenny from Sweden. Craig from Costa Mesa. Alex from Wales, and on and on and on. All sorts of great people here. We've done a great job establishing this wonderful community. Thanks so much. Okay, it is the top of the hour. It is 8 a.m. here in sunny southern Idaho, so I'm going to go ahead and get started. Thank you so much for joining me and welcome. This is a special live stream update on the situation in Iceland, along with some viewer questions and answers. I'm Geology Professor Shawn Willsey. It's about 3 p.m. in Iceland, as I said, 8 a.m. here, Mountain Standard Time. And again, we had hoped to do a drone flight with Nature Eye over some of these young lava fields, but they had some technical issues, so we'll get that rescheduled, and hopefully that'll happen next time. But I still wanted to go ahead and go through with the live stream so that folks could discuss some things. We could also, we're going to unpack a little bit of my interview on Friday with Professor Thordarson. We'll do an update because there's a couple of new pieces of information as we look at Iceland and what's going on there. A couple pieces of news, thanks to Amanda Jo for sending those my way. And then we'll wrap up with some Q&A. So we probably won't go as long as we normally do. Our family also has a little pickleball outing this morning, so I want to make sure I leave in time to get ready for that. But I think it'll be good and hopefully it'll be worth your time. So thanks so much again for joining me. So let's get right to it with the Iceland update. And what I think I want to do here is start with some of the data, as we often do. The Met Office had a very interesting and detailed update that came out on Friday of this past week. So I haven't been with you folks since Thursday for our live stream. Friday, of course, was my interview with Professor Thordarson, and I got that up and posted as quickly as I could. Had great responses from you. We'll unpack that later. But this is an update that came from the Met Office on Friday. And so I do want to walk you through this. I think they have some interesting things that I've never seen before presented, and maybe this is something they have done in the past, but it was a bit new to me, and I thought it was pretty insightful. So let's go ahead and start with this. So magma volume beneath Svartsengi reaching similar level as prior to last eruptions. Well, we knew that, right? We knew that the amount of magma accumulating in the subsurface beneath the power plant area had more or less reached the same volume as what we'd seen in previous eruptions. And that's why we're all on pins and needles waiting for this thing to erupt yet again at any point now. Could be while I'm doing this live stream in the next 20 minutes, could be in the next week or two. So they talk about the warning time being quite short. So model calculations indicate that approximately 5 million cubic meters of magma had recharged the Svartsengi reservoir as of February 22nd. Considering the trend observed prior to previous volcanic eruptions in the Sunnukur crater row, so that's the craters that erupted just to the east of the power plant, the likelihood of an eruption is very high once the volume reaches between 8 to 13 million cubic meters. So based on what we've seen in the past, that range of magma seems to be the threshold needed to trigger an eruption. And in my interview with Professor Thordarson, he had a good analogy of kind of talking about, the pressure's building, and then once the pressure builds enough that the lid kind of is lifted, then the magma is able to escape. There's an eruption, the pressure's released, the lid drops back down. Based on the results of the model calculations, this could occur early next week if magma accumulation continues at the current rate. So again, any day now, essentially, where tomorrow essentially is the beginning of the next week. It should be noted there's a degree of uncertainty, and it cannot be assumed that the behavior will be identical to the past eruptions here. So that's the blanket scientific statement, is we can't take past events and trends and necessarily project those out with absolute certainty. That's a good caveat always to put out there. Also, as the magma plumbing system evolves, we can't rule out the possibility that the volume of magma required to trigger a new diking event or eruption may become reduced. So the system can change at any point. Additionally, there's possibility a new dike intrusion occurs within this region without resulting in a volcanic eruption. So they're covering all their bases there, right? It's a volcanic system. It's underground. We don't know exactly how it's going to play out. Then they have a nice little graph here that shows the 5 previous magma intrusion events and the inflation that went along with those and then the volume of magma that was ultimately either erupted or intruded. And so if we start with chronologically the red line here, right? Yeah, that's the right one. No, sorry, the red line. So this would be from October 25th up until the magma with all the earthquakes that accompanied it intruding and moving and injecting itself to the east of the power plant. So this was the magma inflating. The area was being uplifted around the power plant. That went on for about 15 days. And then we had that intrusion of magma off to the east there, and all the earthquakes, and Grindavik was evacuated. And then the blue one goes from November 19th, so about a week or so later, up until the December 18th eruption, the first actual eruption in this sequence at the end of the year, just before Christmas. And so you can see the volume of magma, estimated, of course, this is modeled, the total amount of magma, which got up to about 18 cubic meters of magma over the course of about 27, 28 days, it looks like. Then we have in green, so after that eruption on December 18th, so going from December 19th to January 13th, that would be the green line, the inflation that restarted, right? So every time there was an eruption, we started back at zero, more or less, and the inflation began again. And that one went on for about 25 days. Of course, that culminated in the January 14th eruption. So then the pressure was relieved on the system. This particular GPS stations dropped near the power plant. And then we go to the yellow line, which shows the magma inflation from January 15th to February 7th, which was about 22, 23 days, somewhere in there. Excuse me. And then this last one is the purple one. So then we had the February 8th eruption, and then the purple line is the inflation since that February 8th eruption. So, and this last data point is February 20th. So that's about, 5 days, 4 days, 5 days old. And so you could just imagine, 5 more dots beyond that purple one there. So the point is we're entering the region from about day 15 or so out to day 28 or so, where in the past, over these past few months, we've seen eruptions generated. So nice little graph there. And then here's the part I really want to get to that I think is pretty important. Let's see. Let's start here at the top, though. This is good here. If an eruption occurs, we estimate the magma will most likely propagate from the reservoir beneath Svartsengi towards the Sunnukur crater row, resulting in lava fountaining and lava flows in the area between Stora Stogafelt and Hagafelt. So those two prominent hills just to the east of the power plant, we think it'll be pretty much in the same area we saw the December eruption and the February eruption. The primary signal of ascending magma is a sudden increase in seismic activity with many localized small magnitude earthquakes. Considering the previous volcanic eruptions in the area, an eruption could start with very little warning, less than 30 minutes, depending on where magma reaches the surface on the Sunnukur crater row. So the idea here is we've already established several pathways for the lava to take to the surface with the prior eruptions. It won't require a lot of seismic energy or activity to get that magma to the surface now that those conduits are established. Therefore, the next eruption will happen, or what could happen, very quickly with very little warning in terms of seismic activity. So they lay out here 3 scenarios that are possible based on what's happened in the past. So precursor, sudden localized and intense seismic activity with small earthquakes, deformation over the magma dike, if there's a dike, and the magma reservoir. Okay, so that's uplift, right? And we've seen that. Very short warning times because the new dike propagation may not be required for magma to reach the surface. Lava reaches Grindavik Road in less than 4 hours. Okay, so those are the things that have played out in the past, and those are the things that are likely moving forward. And then they have sort of a couple different scenarios here. So we could have an eruption to the south by Hagafelt, like we saw on January 14th. And if that were to occur, they lay out, I guess I won't read these all to you, but they lay out exactly what would take place here. Basically, small earthquakes, warning time of 1 to 3 hours possibly, and lava possibly reaching those berms and barriers near the town within an hour or so. If we get eruption inside of the barriers around Grindavik, so if it was even further south than that. So the first one they lay out here is something like the December and February eruptions in terms of locations. The second one is like the January 14th eruption. So we've seen those two. We know what those flavors look like. And then the third one they offer up as a possibility is something even further south in town. Seismic activity would take maybe 1 to 5 hours, and so that's because we have less pathways for that magma, right? We have that one little tiny fissure that erupted near the houses, but in order to get the magma closer to the town, we're going to need to open up and create some pathways, which would conceivably require more earthquakes, more seismic energy to widen out those existing fractures and fissures. It's possible that an eruptive fissure will open within Grindavik or the area just north. Similar activity occurred on the 14th. Although there's a clear indication of uplift in the Svartsengi Thorbjorn area, it does not mean that it's the most likely location. And I talked with Professor Thordarson about that. We talked about something about the rocks around the Svartsengi power plant are different, are stronger, and therefore not as likely to fail and cause an eruption up towards the surface. The Met Office goes on to say this is because the magma reservoir is currently failing on its northeast edge, feeding dike propagations which are initiated towards the east. In a scenario where magma sends toward the surface directly from the Svartsengi reservoir, so if it were to occur where we had magma coming straight up through the magma body and right towards the Blue Lagoon and the power plant area, it's estimated that the first signs of magma migration would be detected 4 to 7 hours before magma reaches the surface. So we would see a series of earthquakes getting shallower, moving their way up towards the surface, and it would take multiple hours for that to play out. Anyway, an interesting update with a little bit more detail. I hadn't seen anything from the Met Office in the past where they lay out possible scenarios, but it makes sense, and they're using what we've seen in the past there, this recent history, to lay that out. So pretty interesting. So I thought that was worth mentioning. I hope you enjoyed that as well. Okay, let's go to earthquake activity, since we just kind of mentioned that. And so here we are, the past 24 hours. Probably a little bit more activity overall, just looking at the map, than what we saw last Thursday, but not much. And certainly nothing to be hugely alarming. There is a small little cluster just to the east of Silingarfelt. And let's see, that's 5 kilometers depth. That's 4.5, 4.9. So probably worth monitoring this little cluster here. But nothing that says an eruption is likely. Again, because we have these established pathways, what should we be watching? Should we be watching the earthquake activity? Yes, for sure. But now that these pathways are established, I mean, there's a good chance that the first indications of the next eruption might be the webcam, right? Like you're watching that's why there's so many people that enjoy those live from Iceland webcams. You can just kind of pop that up in the background while you're baking cookies, and maybe be among the first people that actually spots an eruption that's beginning. So we'll kind of stay tuned to this, but right now I'm not seeing anything huge on the earthquake front, but this little cluster here would probably warrant some, just monitoring moving forward. These all took place, hours ago, so these aren't that recent. I mean, they're within the last 24 hours, but they're still a good, it's afternoon in Iceland, and these were like early in the morning, most of these. Some of these were after, they were like in the middle of the night. So nothing much has happened in that area in the hours since. So probably just a small little stress release, or a slightly bigger earthquake here, this 1.3, and maybe some small aftershocks there. Um, okay, so let's look at the GPS data as we always do, which is helpful. And let's start with Svartsengi. Um, and let's kind of zoom in a little bit here. I think I've explained these enough. I don't know if I need to continue to explain them, but this shows these red dots are all for this particular GPS station near the power plant. Each red dot is taken about 8 hours from the next and records the elevation of that particular GPS station. And so you can see that the trend has been that the GPS station has moved up. And as the elevation is moved up, we correlate that with magma inflation. So more magma is being injected into the subsurface, causing the land to rise. And since the last eruption on February 8th, you can see this thing, it has a nice trend upwards, but it's not perfectly linear. There's some dips in here. There's even a place here where it actually looks like it might have dropped a little bit for maybe a day or two. Just very slight deflation, but then it picked back up. So it's fits and starts. It ebbs and flows a little bit. And so the important point I think to make is that we're above or at, darn near at, if not slightly above, the elevation that the area reached prior to the February 8th eruption. And so that's why everyone's pretty much on guard and focused on what might happen next, because it's really just not a matter of if, but of course when. And that could be again in the next 20 minutes. It could be tomorrow. It could be later next week. It could be 2 weeks from now. We just don't know exactly when this thing is going to take place. So part of the game of dealing with volcanoes is some of the uncertainty. But that's what makes it fun, right? A little bit of the surprise factor and just kind of watching the data and see how things evolve. This is the Elvert station and similar trends here. It is interesting to note that with a lot of these, especially this last one in February, it looks like it inflated, but then it actually flattened a little bit. The overall trend here is not as steep, and so there was some, the idea would be that the land is rising, inflation is occurring, but you do get to a point where the elastic limits of the rock, the ability of the rocks to rise and the land to be deformed, you do reach a threshold where that's just pretty much at its breaking point, and then that was just sort of maintained for a couple days, it looks like, and then we had the eruption on the 8th. And the question would be, are we starting to see the beginning of that here as we look at this far right little cluster? Are we starting to see, I don't know, the data on this station is maybe a little bit too scattered with error bars that are a little too big, but maybe if we looked at some of the other ones, you could make an argument as to whether or not we're starting to see that or not. Let's look at this one here. The Blue Lagoon one's kind of interesting. Yeah, similar sort of thing here. It's going up, then it kind of flattened out. We didn't quite see that in the prior two events, so I wouldn't say that's reliable. And if anything, it looks like there's a little lull here a few days ago, and then maybe a little bit of an upwards kick here. So time will tell, but the GPS data is interesting to monitor, as is the earthquakes. Okay, what I want to do now, so our good friend, one of our viewers, Bruce Garner, I enthralled you last time with his great animation of earthquakes on the Reykjanes Peninsula, and we went all the way back to, I think, like 2009. So we looked at 15 years of earthquake data, and we saw those earthquakes come and go, populating different regions, different systems, tectonic volcanic systems on the Reykjanes Peninsula, places where we expect there to be earthquakes, like over in the Krýsuvík area, Lake Klevervatn, down near the tip, the southwest tip of the peninsula. And he also has sent me, so I think it's worthwhile to look at these, some just good old bar graphs. So now we're going to have fun with bar graphs, team, and this is going to be great. So he's actually put together a series of these bar graphs, which are pretty telling. And I mean, this is the raw data, so this is where you really just want to dive into this stuff if you geek out like I do. A series of bar graphs looking at earthquakes and looking at earthquakes over different periods. So what he has here is going from 2000 all the way on the left to 2024 on the right. Of course, we're only a couple months into the year. And this is total earthquakes. So the size or the height of each of these bars represents the total number of earthquakes on the Reykjanes Peninsula in that given calendar year. The colors he has used, the blue, pink, yellow, and there's actually a little smidge of green there if you can discern that, shows the magnitude of the earthquake. So the blues would be magnitude 0 up to about a 1, pink would be 1 to 2, orange would be 2 to 3, yellow would be 3 to 4, and anything in green is above a 4. And really, I think this relationship will always be the same. You're always going to see more of these small magnitude quakes and fewer of the higher ones as you go. So what you can see here is, earthquakes coming and going. 2009, there was upwards of 5,000, 6,000 earthquakes total on the peninsula. And then boom, 2020 is the big, where this thing really starts to spike. So are we seeing a drastic increase in the number of earthquakes on the Reykjanes Peninsula? Yes, this graph shows that demonstrably. What I was trying to make an argument for last time is that let me back up. A lot of these quakes, though, in the last 4 or 5 years, and 2024 is small because we're just getting started. There's no reason to believe 2024 won't be similar in size once we get going. But a lot of these quakes here are the small earthquakes that are generated when magma is rising and then, of course, there's an eruption. So because we saw both the combined effects of tectonic activity, stress-related earthquakes, and volcanic activity over this period, that's why we have such a drastic increase in earthquakes here. My argument I was trying to make last time was that earthquakes have happened on the Reykjanes Peninsula, since the beginning and in these clusters. So we shouldn't necessarily jump to conclusions when we see earthquakes on the peninsula happening in any given area over some short period of time. The trick is, and I talked with Professor Thordarson about this as well, and I asked him the question, and his answer was, well, you tell me, and that is discerning between earthquakes that are tectonic in origin versus earthquakes that are magmatic in origin, that are related to magma ascent and migration in the crust. So let me go through a couple of these here. So this is the year. There's Bruce's graph there. This one shows the same time period. And so the y-axis here is total number of earthquakes. And hopefully you guys can see those numbers there. I think that works okay. And so you can see them spiking. So this is looking at months, right? So there, you can actually get down to the nitty-gritty details of like what exact month was the most productive. And let me pull up on my other window real quick here. If I can. He also sent me, he has a little bit of text that went with each, so I want to make sure I capture the essence of those. Yeah, so there we are in 2020. 2021, you can see a huge spike there. I think that's around like March or so. So that's the beginning. That's the first eruption. So why is there one huge spike right there? Looking at this graph, I would venture to guess that that's because that's in March of that year. That's when we had the Fagradalsfjall eruption that lasted for 6 months. And so as that magma found and established and widened a pathway to the surface, you see a lot of earthquake activity go along with that. He's got a bunch of these graphs here, so I don't want to spend too much time on these. Oh, man, Amanda Jo says my dumb face is in the way. All right, there we go. You don't need to see me. There you go, team. Sorry. Hopefully that's helpful. So yeah, so this one again just shows the earthquakes over the years. Okay, and the numbers are small, but 2020 is where this thing really starts inflecting. That's when we started really seeing signs of magma intrusion on the Reykjanes. And then our first eruption was March 2021, which coincides pretty well with that. There was another eruption in August of 2022, which coincides with that spike. And then I think he's got some other graphs that'll show these a little better than me trying to figure them out on the fly. But presumably some of these other spikes here at the end are some of the recent eruptions we saw as well. So here we are again looking at, now he's just focusing in on from 2019 to 2024. So the last 5 years on the Reykjanes Peninsula. And again, total number of earthquakes. So 2019, not much, right? And then you can see things starting to ramp up at the end of 2019 in December. These are by month, okay? January, February, March. okay, 2020. And then things really start to take off. It looks like in February of 2021, and then March 2021 when the eruption begins. There's that big spike right there. Once the eruption is established and the pathway is open, notice how quickly the quakes drop back down. So as we go through the spring and summer months of 2021, there was lava being pumped to the surface at a fairly constant but slow rate. But notice how quickly the earthquake activity dropped back down. And then that eruption ended, I think it's September. So you can see about here's when it dies. There's another little kick here, 2021 in December, but no eruption at that time. But we did have some earthquake activity. And then our next eruptive event, things actually got really quiet from 20. Oh wait, here's our next eruption event. It's right here, August 2022. So there was some buildup here. So these could be earthquakes, tectonic earthquakes, you know, and then possibly the magma exploiting some of those fractures there leading up to that. It's messy. I mean, knowing exactly which earthquakes are related to which sort of entity is kind of tricky. So then that eruption ends. Earthquakes drop back down until the summer of 2023 when they ramp back up and we have an eruption to the north of that area near Litlihrutur. And then that drops back down. That's a short-lived eruption. And then we have the big spike in earthquakes that we saw in November of this past year when Grindavik was evacuated. And then interestingly, the December 2023 eruption, the January and the February are kind of small. I mean, compared to some of these big spikes. They're sort of medium months, I suppose, in terms of earthquake frequency. Here's another one showing, again, total number of earthquakes. This is by day, though, so every single little bar graph here is an individual day. So this allows you to really define, okay, when did things really jump up? So you can see 2021, February 24th of 2021. I don't think the eruption began until a few days later. In fact, I think Bruce on his email nicely summarizes this for me. Yeah, so there's a big uptick in earthquakes on February 24th. And then the eruption doesn't begin until over here in March, he says, with like 36 days warning. So that's a good example of like how one of these systems really gets established, right? You need a lot of earthquake activity over many days before the actual eruption begins. I don't think the eruption began until late March of that year. He didn't put that on his email. We could look that up, but that's probably a pretty good estimate. Here's another one so now he's moving through time. This is 2022, the summer of 2022. Big earthquake uptick on July 30th. And then the eruption starts on August 3rd. So that's about 4 days warning. So the earthquake activity, the increase in earthquake activity precedes the eruption by about 4 days, as opposed to the previous event, which was about 36 days. So we can see a much shorter lag time, if you will, prior to the eruption, and then everything dropping back off. And then the next one he's looking at here is this last summer's eruption, and activity jumping up on July the 5th of this past year. There's that big spike right there. A little bit of a warning maybe on July 4th where it kind of ramps up a bit. And then the eruption here is on the 10th. So that gives us about 5 days. So very similar to the 2022 cycle. Interesting. And then everything just dropping back off. And then this graph is, so 2023, so that eruption is over last summer. So now we're going into this past fall. Yeah, there's a few little spikes up here, but then things don't really kind of get going until late October. So there's October 25th when things really start to bump up. The Reykjanes area is very active with earthquakes from late October, and then of course that reaches a really big crescendo, if you will, on November 10th when we had strong earthquakes. You can actually see right here, I believe that's the 10th, you can see the green, which is the stronger earthquakes. It's a sizable amount of the total of earthquakes here. Usually you can't even see the little green top to these bars, but you can definitely see it here. And that, of course, was the shaking and the intrusion, the formation of the magma dike that resulted in the evacuation of the town. And then things getting quiet as we went through November, and then we had the eruption on the 18th of December. So there's the spike there in earthquake activity, but really not much of a warning. I mean, there wasn't much, a little bit of a ramp up going from the 15th to the 16th to the 17th of December. But, more or less looked like background amounts of earthquakes. And that's why you just can't look at total number of earthquakes. You have to look at where they're occurring spatially and clustering. You need to look at depth. So these graphs are great, but this is just one component. All he's doing here, and I'm not dismissing it, they're great graphs, but what we're looking at here is just time in different components, right, on the x-axis, and total number of earthquakes. But there's so much more to analyze when you're looking at this earthquake data. Okay, and I think this last one, this one just shows magnitude 4s. So if we just isolate the magnitude 4s, we can really see how strong and how many of those. There was over 30, like 33, 34 quakes over magnitude 4 on November 10th, and that's what just sent the whole town into evacuation mode, was that craziness there. A couple more of these. Hopefully you're hanging in there with me. And again, shout out to Bruce Garner for being able to put these together. Thank you, Bruce. These are very helpful. The other graph he sent me is this shows, so now we're looking at December of this past year, so just a few months ago, up until a few days ago, February 17th. So this one nicely shows our last 3 eruptive events, right? So here's the December 18th eruption, the first spike on the left. Here's the January 14th eruption, the one closer to town, where we caught the fissure opening up that destroyed 3 homes. And then here's the February 8th spike here. So it'll be interesting to see, if we can get Bruce to put this together maybe again at the end of this year, at the end of 2024, like how many of these spikes will we see? How many eruption events will there be on there? I think that'll be interesting to look at. And then he's got a couple more here. This is just daily, so it just shows those 3 spikes again, just earthquakes by day. But you can see sort of a little bit of an increase, then a lull, then the eruption, a little bit of an increase, then a lull, then the eruption, a little bit of an increase, a lull the day before, and then the eruption. So there might be something to that little trend there. There's this quiet pocket there, but it doesn't look predictive, right? You could also look at some of these other days, like, for example, January 19th, when there was a uptick in earthquake activity and then a lull. That's why we need to also see where these are occurring, right? Where are these earthquakes at? What is their depth? More of an aerial spatial view in conjunction with this would be helpful. December 18th, so I was just looking at quakes per day. I think at some point here, Bruce just he obviously loves this stuff. I would have made a couple graphs and then said that's good enough, but some people just love analyzing it every which way, and that's great. We need people looking at things from multiple perspectives. There's the the December 18th eruptive event in terms of earthquakes. There's January 14th. So these are just looking at, the days preceding and following each one of these eruptions and just looking at the total number of earthquakes. January 14th, interesting here, we had, now he's doing it by hour. That's pretty interesting. So each bar on this one is by hour, and I'm not sure exactly, well, actually, so this shows us a couple of hours before those eruptions took place. I'd have to look at exactly when those took place in terms of hour-wise, but pretty interesting stuff. And then here's the last one in February. So very cool, Bruce. Excuse me. Thanks for putting those together. Yeah, great colors that you chose here on the graphs. Very easy to read, very visually appealing and impactful. So, I think we want to look at maybe a lot more of these cycles and eruptive periods before we maybe make any sort of grand conclusions, but there's definitely some interesting observations to be had there. So let's look at some of the news going on. So the big, awesome news out of Iceland for Grindavik residents like Amanda Joe is that the much anticipated bill to purchase people's homes in Grindavik by the government, that bill has passed. So that bill was accepted. It's law now, and they're probably just working on the fine details. But the good news is folks like Amanda Jo who've decided, and she's told me that there's more or less broadly three camps of people in Grindavik. There's those who have decided that for now they're going to stay, they're going to keep their house, they're going to maintain their property as best they can and just see what happens moving forward. There's another group like Amanda Jo and her husband that have decided we need to cut our losses here, and they've already found or are in the process of finding another home somewhere, and so they're ready to sell. That's why they were eagerly anticipating this bill. And they're ready to sell their property in Grindavik and move on with their lives. And then there's a third group that's kind of not sure. They haven't decided one way or another. Are we going to sell? Are we going to stay? What are we going to do with our property? What does the future hold? And so she's relayed to me that broadly people fall into one of those three camps. But great news for her, because now Amanda Jo and her husband can move forward on the house that they made an offer on in a different town. They can now get the financing they need to start the process of purchasing that home. So that's really great news. Other than that, there's not a whole lot of Iceland news that was out there. As we mentioned before last week, they have opened up the town to residents. So now residents can stay in their home if they choose to 24/7. And I think what we're seeing here, and we've seen this we've seen this with other events in the world over the past few years, is that when there's a new threat, when there's a new risk, we oftentimes, and it makes sense, I would probably make the same call if I was calling the shots. We're reactive, and we start with a very measured, conservative approach because we're not sure exactly what's going to happen. So the evacuation of the town and everything that the Icelandic community and government did, I think was the right call personally. You just didn't know. But now that we're a couple months into this, and it looks like there's maybe this semi-regular behavior of inflation, an eruption, most likely in this area here, that lasts for a couple of days, and then everything gets quiet, and there's deflation, and then we resume with another inflation cycle. I guess my point as I'm trying to make here is that it's becoming more comfortable. I think in Iceland as a community and as a government, they're becoming more accepting of the risk. Their tolerance of the risk that exists has probably increased a little bit because now, even though things could change, but now we're not anticipating an offshore explosive eruption or, some eruption pouring out 10 times more lava than one of these other eruptions and going on for months. And so for now, I think that their approach is a little bit more measured, and that their approach is a little bit more calculated in the sense that there's more data, so now you know exactly what you're dealing with. Whereas back in November, we had no idea what was going to happen. I mean, I even had videos where I'm like, eruption imminent on, November 10th. That was like, the feeling was like there's very likely to be an eruption here at any point. And of course, there wasn't an eruption in November. We had to wait another month for there to be an eruption. And so things are, I think, I don't say returning to normal, but there might be a pathway forward where businesses can resume in Grindavik. It would make sense that maybe people don't want to live there full time. That's going to be a personal decision that they need to make. That the Blue Lagoon can open again, and it is open as we speak. I talked a little bit with Professor Thorsson about, will there be public access into these flows? And I think I saw something about you can actually drive in here, and there was people out walking on the new lava flow, and which probably isn't a good idea, especially with, a couple of reasons it's not a good idea. It's just safety-wise, and there's another eruption brewing and possible. And we know based on what we just talked about with the Met Office that the next eruption could only have 20 minutes warning time, so it could happen quite quickly and escalate. But I think you're seeing just a tolerance of this new volcanic behavior in this region I just think you're seeing it becoming a little bit more acceptable and adjusting. And that's kind of, human behavior, I think. It's an interesting social experiment. So at any rate, interesting. So, okay, so let me switch over to many of you maybe saw the interview I did with Professor Thorlerson, and that's available on the channel as well. That was on Friday. I posted that. I thought maybe we could discuss, and there might be some questions that come through on the live chat about exactly some of the specifics we talked about there. I thought he did a great job. I appreciated him getting back with me, agreeing to do the interview. He actually was a few minutes late because he was visiting his mom at the hospital. So very gracious with his time. I thought it flowed really well. It was my first interview with another geologist on this platform, so I was, of course, a little bit nervous and not sure if I had too many questions or not enough questions, and would there be awkward transitions. Those are just things you're not sure of in terms of the flow of a conversation with a colleague like that, especially one that you're going to put for the world to see and post later. But I thought it went really well in terms of just back and forth, just his approach and his rapport. I already respected him, but in getting to know him more, I think that just grew a little bit. He seems to be a nice straight shooter of a scientist, which I appreciate. He wasn't prone to hyperbole. He didn't seem to have a lot of ego. He wasn't trying to promote one narrative. He seemed open to the data and the changes in the data that we might see going forward. And I just thought it was pretty interesting. Some of the things we talked about in there that were pretty interesting is we talked about the volcanic system. If you look at some of the, take some of this stuff down. If you look at some of the literature in the area, you see that the Reykjanes Peninsula has been defined spatially on a map as having, one system over here, the Elverup system here, the Svartsengi system, and there's these northeast-southwest trending belts of volcanic activity, all the way up towards Hengil up here, or over here. And he argued that, there's no reason to define them separately, that they all seem to have the same or very similar magma chemistries. They all seem to imply that they're coming from a common source. So that was kind of neat to see him talk about that. These are just a few of the takeaways I had from him. He also talked about, we compared a little bit Hawaii and Iceland and discussed that one of the differences among many is that in Hawaii, you have these bigger volcanoes that stick up, thousands of meters out of the ocean, and the magma storage reservoirs that feed the eruptions are located in those volcanoes, higher up in the mountain, if you will. Whereas in Iceland, we see the storage zones that feed the eruptions are down in the crust, and so there's some differences there in terms of where the magma is stored and sort of how that plays out as we go into eruptions. We talked a little bit about the area under the power plant and why it might be different there. Why are we not seeing an eruption right here? If the magma body is sitting more or less in this area, why is none of the magma coming up? Why is it moving off to the east and causing eruptions out in this area? And so we talked about some of the other rock types that might exist there. He had a real cool take on this volcanic breccia called hyaloclastite. Basically, it's a rock that we commonly see in Iceland that forms when an eruption is underneath a glacier or in water, so it's more fragmental, a bit explosive, but that produces this shattered rock that then gets compacted and compressed into solid rock, but it lacks a lot of fractures. Like the basaltic lava flows tend to have a lot of fracturing in them, and so he surmised possibly that there's some of that material sitting underneath the power plant area, and because it's not very permeable, that's not allowing the magma to migrate towards the surface there. And also maybe it has some elastic properties that allow it to sort of, bend and heave and move without actually breaking. which was interesting. And that's something I've wondered and talked about as well. And then we laughed a little bit about the fact that, there's people literally bathing, soaking in a hot spring, more or less right above this magma chamber. But this shallow groundwater system that the power plant taps isn't affected by it at all. So whatever rocks are down there, they're not allowing the magma's heat and energy to be transferred to the shallow groundwater system that the power plant operates on. So just a couple of takeaways there. And then towards the end of the interview and discussion, we talked a little bit about the response by public officials, being reactive versus proactive in terms of your hazard response, and a little bit for what the future might hold moving forward. So if you haven't seen that, that's there. I probably need to watch it again just to kind of digest everything. I think in the moment I was trying to, stay with him and keep the conversation going, but I don't know if I fully digested everything he said in the moment, so it'd probably be good for me to go back and watch that again. So hopefully that was helpful, though. And I think he seemed open to doing it again. Maybe we'll allow a couple of months go by or another eruption or two, and then we can circle back to him and ask him some questions. But you're always welcome to send me questions you'd like me to pose to him if and when we get that set up. So awesome. Okay, well, team, one last little programming note before we get to your questions, and those should be, of course, on the live chat and sent there. So Amanda Jo, if you can send me the first batch of questions, that would be helpful. Make sure you do hit the little thumbs up like button on your screen there, friends. That always helps. What it does, apparently, I don't know how the whole algorithm works. It helps increase the visibility of our program, which will attract more people that might be interested in this sort of thing, help us sort of grow the community, grow the geology education that I'm so passionate about. So make sure you hit that. I do appreciate those of you that on the live chat are making sure that those things happen, because it's very helpful. I think the last thing with the interview to mention is that because this went so well, it did get me thinking of doing more of these in the future. And I've already started a playlist on my YouTube channel that's an interview series. And so I'm in an interesting place because I teach at a college where I am basically the only geologist. I don't have colleagues that I rub elbows with every day. And so I'm somewhat isolated in that sense. But I do know some geologists, and most are pretty approachable and would be agreeable to appearing on something like this. And so I actually came up with a list of just low-hanging fruit, like geologists I knew, topics that we might discuss with them that I think folks would find interesting. And so I probably will start to do that on some sort of a regular basis, maybe once a month, maybe something like that. It obviously won't always be Iceland as a topic. I'd like to explore some other topics as well, but you can look for that possibly moving forward, because I think it's great to bring in other folks. I never have claimed at any point that I am the geology expert, that I wanted to be the star of the show. I just want to share geology. I want to learn myself. So talking with Professor Thorlerson was a great learning opportunity. And I think that would be a great thing for us moving forward as a community. So, okay, so as a quick programming note, and then we'll get to your questions. So the next Sunday, March 3rd, at 10 a.m. Mountain Time, which is 5 p.m. UTC, I will be doing an interview with Nick Zentner, who is a prominent geologist with a YouTube channel, lives in the Pacific Northwest, teaches at Central Washington University. He has done way more stuff than I have in terms of just public outreach, but we're sort of on similar paths, I'd say. We both have YouTube channels, but he's way more prolific than I am. And I want to have a conversation with him next week, a little bit about how his public outreach component of his job, which I think is really more of his passion than his job, if we're being honest, but sort of how that developed over time. So we'll kind of take a step back. We're not going to do a full biographic history on Nick, but I do want to kind of work through how that worked for him. How did he start out as an instructor at a college, and when did he decide that he wanted to start doing more and interacting more with the public? I want to have a bigger discussion with him about just science and how we present science in the public eye and some of the limitations and problems that exist there, because I think there are some barriers, unfortunately, in that regard. And I don't know, we'll just see where it goes. It's going to be an organic conversation. So if you enjoyed my interview with Professor Thordarson, or if you like watching Nick Zentner and his content, then this might be a good forum for you. So we should have a nice big audience because we'll sort of be combining the two groups, although we have quite a bit of crossover between us already. So look for that next Sunday. I'll get the thumbnail and the little link set up sometime this week, so you guys can look forward to being notified of that and knowing that that's going to take place. So, okay, let's go ahead to your questions now. And I won't be able to do as many of these as I've done in the past. So I've told Amanda Jo probably just like 3 pages of questions will probably be it for me, because I've got a few other things going on this morning. Okay, let's go ahead and get started with the questions then. And thanks to all who sent them. The questions are fun, but I sometimes get a little bit nervous because you just don't know what someone's going to ask, and you want to have a good answer, and you just never know. Okay, from Shauna Guthrie. If you were a betting man, which I'm not really, which day would you put your money on for the next eruption? Yeah, and I mean, what's funny is those questions are, I always cringe when it's asked of a geologist, but then in interviewing Professor Thordarson, that I was very tempted, and I essentially did ask him more or less that. But so I guess it's human nature to kind of, you're asking someone's opinion. So obviously I have no idea when the next eruption is going to take place. Amanda Jo thinks it's going to be Monday or Tuesday. Professor Thordarson, in another interview with someone, suggested tomorrow, Monday, as the day for an eruption. I think it's going to be a little longer than that. So if I had to pick one specific date, I'm going to say, you know what? I'm going to say Friday, March 1st. If for no other reason, then that sounds great. That puts us into another month. Yeah, why not? Friday, March 1st. It would also be a good day for me personally, looking at my schedule, because I don't have a lot going on. So if the eruption was on that day, that would help me out, and I could hopefully get some videos going and live stream and respond to it much better. So I'm not putting money on it, but that would be nice. Joanne, did you get information from the interview on Friday for the professor's sources for some of the conclusions he's drawn, as mentioned in prior sessions, that you'd be interested in learning? I think I got some clarity on some of his answers and things I'd seen in the press. So I did ask him about one of the things that I'd wondered about, that I'd seen in some of his statements to the media, was, and it wasn't just him, it was other Icelandic geologists, that, I mean, early on, since November, this area, the Eldvarps crater series over here, this has been discussed a lot by a lot of different Icelandic scientists. And I just wondered why. Why are you speculating the possibility of an eruption here? And then as things, progressed up to December, when we had the eruption over here, there was still some discussion and some media reports that we might see an eruption here. And I did get some clarity from him in the sense that these fissures that erupt are on tectonic weak zones in the Earth's crust. And so it is likely and possible and even probable that we see them erupt again. And certainly we did see that here, right? Now, it's not perfect here, and of course my map's not perfect, but there's this older, let me take some of these off here so you can see this a little better. So there's this older crater system that kind of runs through this region. Did the recent eruptions occur exactly on those? No, but pretty close, right? And in fact, some might be right on. I think the December one was more or less right along it. So we have seen some of these reactivate. And so I guess to summarize, I think what he was basically saying was that um, we had these two systems. I don't know why this one was maybe mentioned more than the Sunuk Giga crater row. He even mentioned sort of, just in jest, I suppose, that it might have been wishful thinking because this system erupting is obviously more hazardous because the town sits down slope, whereas if we had an eruption here, there's not much there for the eruption to compromise. So yeah, so I did get some clarity there. So hopefully that makes sense. From Giles, what are your 7 geologic wonders of the world? Oh boy. Um, I don't know that I can come up with a list on the fly like that. 7 geologic wonders of the world. The Grand Canyon's on that list for sure, to me. Um, any volcano erupting, like I think a Hawaii or Icelandic eruption, would be on that list too. So there's 2 out of the 7. I'd have to think about some of the other ones. Other places I've just kind of been in awe. When I stood underneath El Capitan in Yosemite National Park and looked up at over 3,000 feet, 1,000 meters of just solid granite that represents a solidified magma chamber that had since then been uplifted and then cut by glaciers. Like that was a pretty moving experience as well. So there's 3 for you. Yeah, Grand Canyon, an Iceland eruption, and El Capitan in Yosemite. From Nigel Rogers, have you seen the latest Theia revelations as published on Geology Hub? If so, do you know what technology was used to reveal this new model? I'm not familiar with that. We obviously only have so much bandwidth. I've been really busy this spring with all the classes I'm teaching and just life, I suppose. So I can't comment on that, but I will try to carve out a little space to look into that. PM Ange, could the next eruption be directly in Svartsengi? Watched your interview and the one with Val Troll, and he seemed to say different in both. I'm confused. I didn't see all of the interview with Val Troll. Could the eruption be directly in Svartsengi? It's very unlikely. And I think the Met Office update today had some good information on that. That if we were to have an eruption here, what the signs would be. And they talked about 4 to 7 hours of warning, earthquake swarms here that get shallower. If you look at the seismic data for almost any time period over the last probably 5 years, there's been very few earthquakes in this area. So it seems to be, I think Professor Thordarson said, a colleague even calls it a stress, did I write that down? A stress trap, I think is what he called this area. So there's something interesting going on here in the subsurface where it's just the rocks can be heated, the rocks can move a little bit, but they just don't generate the earthquakes for some reason, which is pretty interesting. So hopefully I answered that. Yeah, the directly underneath Svartsengi, very, very low probability, and we would expect to see some signs preceding that. PMCJM, are all the inflation events the same size laterally? Any sign of spreading in a particular direction? Yeah, when we look at the GPS data, I'll admit to being a little, I tend to look at the uplift data mostly and not so much the north, south, east, west motion, although I do look at it a little bit. I think it's more telling. It's probably a little easier, day in and day out narrative to have people focus on and track and actually see these trends. But certainly we want to look at some of these other trends as well when we look at movement, north, south, east, and west. I hope that's the essence of that question. Yeah, are all the inflation events the same size laterally? Yeah, I think hopefully I answered that. From Sandrine from France, hello. Were you able to ask Professor Thordarson what he thinks about the Svartsengi GPS station not showing a deflation on January 14th? I don't think I heard you talk about that. Yeah, I didn't get to that. I had my list of questions, and I told him we would do about a half an hour. I think we went went over that to like 40-ish minutes. So I'm new at the interview thing, but the way I approached it was I had a list of questions I wanted to get through, and possible topics, but then I sort of wanted the conversation to be somewhat organic. And so I started with kind of big picture stuff, hotspot, divergent boundary. We talked about the Reykjanes area in depth, and then as the conversation about 25 minutes in or so shifted more towards public response, building berms, defensive walls, then I took it that way, and I had some questions in that arena. So, so we didn't get to that. Susie Jones, would you think of the depth as being a cone, where the top of the cone is the surface and the earthquake at the bottom? Hence, we see deep earthquakes, but it may be anywhere on the surface. Boy, I don't totally get what you're saying. So when we have earthquakes, we can tell not just where they are on the map, but where they are in three-dimensional space. So we're able to estimate their locations, and that location is called the focus. The location on the map is called the epicenter. So the focus sits below the epicenter, but it sits at some depth. I don't know if that makes sense. So the earthquakes that we see on a map are just dots. That just shows us where they are, but then there's a third dimensional component in the subsurface as well. So if I didn't quite get your question, I apologize. Robin M., why was the lava much runnier in the last eruption it was in the first two eruptions? It had more power even though the magma is from the same source. I don't know that first eruption had very fluid lava. The December 18th eruption, just looking at it, this is all just anecdotal, appeared to be very hot and very fluid. The January eruption seemed a little bit less fluid, but just by a little bit. A lot of it too can depend on the topography the lava's flowing over. It can actually be measured. There's actually a way to measure lava viscosity. I think they use pascals or some unit of measure for that. Not sure. Presumably it had maybe, it was hotter potentially. That's an easy way to make lava runnier, is have it at a higher temperature. Had more power even though the magma's from the same source. Right, so the magma's coming from depth at the same source, but then it's stored in these shallower reservoirs, and then we're only erupting a portion of that magma out to the surface. So it might depend on exactly how much gas it contains, the temperature. Is it contain a little bit of the older magma with it that might make it less runny? So a couple ideas there. Excuse me, PM Orogenic Man. Could you discuss the possible source of the magma plume as opposed to spreading center magma? Well, in my discussion with Professor Thordarson, we know both processes are operating to generate volcanism on the Reykjanes Peninsula. We know it's both hotspot fed, but there's a component of, because it's part of the divergent boundary that runs through the Atlantic Ocean, the Mid-Atlantic Ridge. So there's some decompression melting as the plates move apart that triggers some of the asthenosphere into melting. And so we have both of those. So it appears as though we have a combined source in terms of the magma we see on the Reykjanes Peninsula. What's not clear, to me certainly, and maybe to other geologists as well, is how much of each is contributing, right? Is it 70% hotspot magma and 30% divergent boundary magma? Is it 50-50, something else? Yeah, good question. Craig Deaton, can aerial gravity survey help define the boundary of the magma sill and its changes? I'm not a geophysicist. I know gravity surveys can help a little bit. I think it depends on the depth of the magma body and the volume. And I wonder if this particular magma body is A, either too deep, and or B, too small to actually use gravity to help discern its actual shape. Right now, what we're doing to figure out the size and shape is going with ground deformation data. We're going with inflation, deflation, the land moving up to quantify or estimate how big that magma body is. So, okay, let's go to the next set of questions from you good folks. Hopefully everyone's doing okay there. Haven't really looked at the live chat or anything in a bit. Kind of focused on the questions as I should be. Okay, sheet number 2 from PMKD. For something completely different, what was the best prank that someone played on a field trip during your career? Oh my gosh. Well, thank you for that bit of levity. I appreciate that. That's an easy one because it just happened. Maybe not the best prank, but it's the most memorable one. So I took students to the Big Island of Hawaii this past May for a class. Great trip, great group of students. And of course, as you know, in Hawaii, all the rocks essentially are basalt. There's different kinds of basalt, a'a lavas, pahoehoe lavas, tephra layers, but fundamentally, chemically, they're nearly identical. So it was probably our first full day. I don't even remember where we were. We were somewhere. I can't remember our itinerary. But anyway, wherever we were the first day, we're out doing geology. We're in the field. And one of the students comes up to me and says, "Hey, professor, what kind of rock is this?" So I look at the rock, and it's, of course, a piece of basalt. And I didn't want to be, condescending or insulting to the student. I'm like, well, it's a piece of basalt. Looks like there's a little bit of iron oxidation on one side, a little bit of weathering. And the student says, "Okay, thanks. Thank you. That's great." I'm like, okay. So then the next day, we were somewhere else, and another student comes up at some point during the day and says, "Hey, professor, can you help me out? Can you help me figure out what kind of rock this is? I'm not quite sure, and I need to write some stuff down." And so I'm looking at it, and I'm like, "This looks like a piece of basalt. It's it was lava that has cooled and solidified." I'm still very patient, right? Then we get to day. So this goes on, but I'm completely oblivious, and I admit to being. If you're going to pull a prank on me, it's not hard because I'm just sometimes oblivious to this. So in the back of my mind, though, I'm thinking, gosh, these are some of my better students. They should know this. They should know better than to ask me what kind of rocks these are, because we've kind of gone over this. They have rock identification skills, whatever. So then it's not till day 4 or 5. I think it was day 4. And I remember now exactly where we were. We were down in the Puna area. We were on the coast, right where the 2018 lava flow went into the ocean. Really cool place. And student pulls out this rock and a different student asked me. So it was a different student every day. And then it finally dawned on me. And what they had been doing was someone had picked up a rock somewhere, but they were showing me the exact same rock. So every time a student each day was asking me about the rock, it was the exact same sample. But never once did I say anything to the student about hey, you should know better, or But it was a good prank. They all laughed. They had a good time. They kind of punked me, I kept that little piece. I hope they collected it somewhere safe. I have no idea where they picked it up. I think it was on the north side of the island, so it was not in the national park or anything. And it's sitting over there on my little display cabinet. So there's a fun little prank. Great question. Thanks for that little break in the action here. From Robin, PM Robin M, how many times can this land rise and fall before it eventually fails? Like if you overbend a piece of plastic, in the end it will snap. Well, the rocks have some elasticity to them. So even though we're stressing the rock by injecting the magma, and that magma's filling space, and the rocks are rising and falling, it can go on indefinitely. So there's no... Now, when we say it breaks, what's happening is when it becomes overpressurized, the land, the uplift and downdrop of the land isn't what's failing. It's failing underground, and it's sending that magma through fracture systems, in this case to the east, and then that's culminating in an eruption. So, yep. Okay, PM Travel Bug. Would love for Shawn to interview Mandy Jo. She's a very special part of the team. I'd love to hear her thoughts and feelings about this situation. That's a great idea. My wife joked the other day, she's like, "You talk to her more than me." I'm like, I do. I text her and communicate with her probably more than you on any given day. She's been great, and we've got to know each other a little bit. I would love to do that. So I'll see if she's open to that. Maybe not. That's up to her to decide. Maybe she can get, just I'm thinking out loud here. It might be cool also if she felt like that was maybe too much pressure. We could also maybe do like a multiple person little panels Zoom thing with some other Grindavik residents, or just kind of get some different perspective. I'm open to it. Obviously, as a geologist, I feel most comfortable in the geology science lane, but I think for something like this, I would feel comfortable talking to people about the more human side of things and that sort of thing, and just trying to learn and manage that as best I can. So great idea. We'll see what she says. So she put the question together. Obviously, if she didn't want to or felt differently about it, she probably would have kept that question out so I didn't see it, but she kept it in there, so maybe she's open to it. PM General Anasazi, I heard that tectonic earthquakes are located under a depth of 5 kilometers. Is that true for this area? No, I don't think the tectonic quakes can be virtually any depth at any given location. I mean, to some degree, right? Like only at subduction zones do we get really deep earthquakes, but in a place like Iceland, we can't look at the depth of the earthquake and say it's tectonic, it's caused by magma. There's nothing sacred about that, because tectonic earthquakes can be very close to the surface. They can also be tens of kilometers down in a location like this. So I don't think there's any correlation there. From Tim Holmes, I'm realizing now that it says PM at the beginning of all your things there. So Tim Holmes, Mandy Jo, is there a link out there for Dr. Willsey's Google Earth map so I can include his data on my own map? I don't know how to do that. So I guess I could send the KMZ files. All I've done here, and I'm working on the backs of other people. All I've done here, team, is I use Google Earth Pro, and I have added certain things. So you can add a little pin. So I've added a little pin for the power plant. I've added a pin for the Blue Lagoon. These are the vents, or pretty close to the vents of the 3 eruptions over here. And then other people have sent me the outlines, and I can't remember the viewer's name, so I apologize, but have sent me the outlines of the last 3 eruptions. So they basically trace it off of satellite imagery, and then it's a KMZ file. And then I even have, so then I put in the protective berms. Again, these probably aren't perfect and are likely to change. I even added the GPS stations where those are. So you can kind of keep those in layers over here. And then I traced out as best I could, kind of looking back and forth between, I think one of the Met Office maps, I traced out the Grabens. So when we had some of those earthquake activities, we had down dropping in the town, I put those in there as well. So, but your question is, can I put links up to those? I don't know. Can I put, maybe someone can answer that and let me know, and I'll look through the chat later. Can I put, I know I can send the KMZ locations as a file, but can I generate a link where people can access it? I'll try to figure that out, Tim. I guess worst case scenario, Tim, is you could get a hold of me and I could send it to you. Yeah, that might work. All right, from Mathis J. SPW, about the bar graphs, would it be more meaningful to graph the amount of energy involved in the earthquakes? Magnitude 4 is orders of magnitude more. Yeah, that would be like just different way of showing it, right? So rather than number of earthquakes, we could plot energy released, and then November 10th would just be like, oh my gosh, November 10th would just be this huge monstrosity of a bar tower, right? Because there was, what, 34, 38, whatever magnitude 4s on that day, plus who knows how many of smaller earthquakes. Yeah, I don't know if it would be more meaningful. It's just different ways of showing the data, but certainly valuable to show it that way. Interesting idea. Tracy Johnson, does the tectonic plate move away from each other? Can that cause a magma intrusion to kind of fill in the gaps? Or what happens when the islands separate? What will happen? So the earthquakes are happening all the time, some of which might be accompanied by what we call extension, right? So it's opening, but some of them are strike slips, so they're shear ones. So not every tectonic movement is going to create space that magma is going to fill. I think that's the first thing to mention. Not all parts of Iceland have the conditions for magma to form. The other thing to think about too is when we have extension and let's say we have a fracture open, that fracture doesn't necessarily go from the surface all the way down to like, 10 kilometers down, right? It has limited extent. It might be offset in places. So it's not as simple as fractures opening and then magma filling in the gap. But I mean, over time in Iceland, that is what happens to some degree. There are fractures on the ground in Iceland that are just open cracks you can walk through. I even have a video on one not too far from the power plant. That's a cool little Lambafellsjat, I think is what it's called. You can just walk through this tectonic fissure, this crack. Then there's other ones where we do get magma intruding into them. Yeah, hopefully I answered that. From JZ, I guess, is it possible from the amount of intensity of earthquakes to deduce the viscosity of the magma? I don't think there's a correlation there. Interesting idea. No, the earthquake, the magmas are created. The magma, regardless of viscosity, and it's really the gas content more than anything. The magma needs to be low viscosity enough that it can move through the subsurface. And then the pressure that the magma has in terms of its volume and the gas content, that will probably dictate the size of the earthquakes and the intensity. If you have magma forcing its way, injecting itself through a fracture, and there's a lot of magma pressure, then potentially that could create a bigger earthquake. You also have to think about the rocks that it's moving through. If that rock can hold a lot of stress and then break at a greater stress, you're going to get a bigger earthquake. But if the rocks are weak, you might get more earthquakes, but they're lower intensity. So more frequent, but lower intensity. So there's a lot of variables there. Jeffrey Porter, if you do a Geology 101, will you be using a textbook the general team members can purchase to follow along? I took physical geology in a community college back in the 80s, never lost my interest. Yeah, I do plan on putting together some Geology 101 videos. I can recommend a few textbooks, but the new landscape of education, at least where I teach in the colleges, is we're actually trying to move away, for the most part, from physical textbooks and allow students access to online textbooks. So for the last few years, there's an online textbook I've been using, and it's nice because it has like little video clips and sometimes animations and quizzes you can do. So I can put links to those up very easily, but I can also recommend a physical textbook because I understand that some people, including myself, like if I have to read like a book online on the computer screen, I read better from the printed page. And so I can leave both options open to folks. So yeah, when I get that organized and kind of going, I will be sure to put either links to some of those online textbooks, or I can put some recommendations for some printed textbooks that folks can go look at. So, okay. There, I'm going to make myself a little bigger now. Tom Day, interesting graphs. I wonder if the short period of no activity is magma filling the space that the quakes have broken rock. Certainly after you open the vents and the eruption is taking place, that is magma filling the space, and you're not breaking a lot of rocks, you're not generating a lot of earthquake. During the quiet periods between eruptive events, though, maybe. Yeah, it's hard to say. Yeah, James Green. Interview yesterday with Professor Thordarson. They were discussing that latest lava is the richest ever seen in Iceland. Could mean that plumbing could be more complex. Then I lost Wi-Fi. Any info? Richest. Oh, he might have been using the word enriched. So an enriched magma, which is more of like a primitive source, I think. I don't know. Yeah, I've never seen the term richest. Maybe enriched. Sometimes we talk about evolved magmas, enriched magmas. Yeah, not quite sure there. I'll have to look into that. I doubt he used this word, but maybe, or maybe it was translated that way. Who knows? Okay, let's do one more round of questions. Let me go find my email and question sheet 3. And thanks again to everyone who's been here so far. We'll wrap this up here shortly. Thanks to Susan and Amanda Joe for all their hard work in running the live chat. Okay, let me change this window here real quick. Apologize. Rock Tapper Robin. Thordarson mentioned transform movement between the plates on Reykjanes Peninsula. Can you comment? Yeah, I'll try to do this with my hands. So he talked about, well, I guess I could pull up a map. Let's get rid of all this stuff as best we can. He talked about the Reykjanes Peninsula is a bit of what we call a leaky transform. So because the direction that it's spreading is not exactly perpendicular to these lineaments, these volcanic and tectonic trends that run northeast, southwest. So because it's not perfectly perpendicular to those trends, but at an angle, that means that we have not just extension, but we have some strike slip faults, transform motion, side to side, horizontal motion across the peninsula. And so a good number of our earthquakes are just that. So we can't assume all earthquakes are opening and setting the stage for magma intrusion, because we might be seeing a lot of earthquakes that are side to side, like the San Andreas fault. And so those wouldn't really allow any pathways for magma to form. I think what I want to do is put together something a little better that kind of goes over sort of the basics of Iceland's geology and tectonic setting, tectonic history, which is pretty interesting. So you kind of gave me some things to stew on there. Thanks, Robin. From Floccular, do you think the human tendency to extrapolate the regulator of the past eruptions poses a risk of overconfidence? I think we're prone to do that. We look at like a few patterns and then we just project it out. I don't know if it's human behavior. As a scientist or someone who tries to be more objective, I try not to do that. I try to just be like, well, just 3 data points on a line that defines a trend isn't necessarily something. So extrapolation can be done, but I think extrapolation done with multiple data points, it can lead to some conclusions that are justifiable. But having a couple data points, like, well, we had eruptions here, here, and here, therefore the next 20 eruptions are going to be along this line, I think that's a little bit, it is overconfidence. It is possibly misleading, possibly irresponsible in a scientific way. So interesting question there. From Bjorn to Baker, what are the possibility that Mount Thorbjorn is the location of the eruption? So that hill or landmark, here's the town, and it's right here. There's a bunch of webcams up here. It's a really fascinating place. I'd love to actually go hiking on it sometime. I know there's a trail up there, because running right through the crest of this hill, you can see these 2 trends. And so it's essentially, it is a graben. This is a fault, one fault here and another fault here, a little bit of a downdropped area between, and then there's some fractures up here that are kind of interesting. You can see sort of this zigzag pattern here as well. But the hill itself, much like all the other hills around Grindavik, are what we call tuyas or table mountains. They are subglacial volcanoes. These are volcanoes that did erupt when ice was covering the peninsula, and it erupted through the ice. It became explosive at some point, and it basically piled up different volcanic material than the lava flows we're used to. And so that's why you see something different there. So could it erupt here? Possibly, but given what Professor Thordarson talked about, this type of rock, this hyaloclastite rock, it's possibly not, well, it's very unlikely that we would get an eruption out the top of any one of these. They only exist because they were under ice at the time that they erupted. And the easiest pathway is going to be for magma to break out into these low areas between these hills and not break out for the top of these. Notice how they don't look anything like, I mean, all these are technically volcanoes. They just don't look anything like a volcano you're used to. There's no crater at the summit. They have steep slopes, which you would not expect from runny, low viscosity lava. So that would be very, very unlikely to see an eruption, at the summit of some of these 100-meter or so hills around Grindavik. Okay, puzzled puzzler. How deep would a new core sample need to be to get older data than we already have? How deep has it been done, and what kind of rock is in the deepest core that's been done? I'm assuming you're referring to mainly Iceland. I did ask Professor Thordarson about that a little bit, and his response was, that's not going to happen now because we're totally in this reactive mode, and our scientific focus is on the here and now, which makes sense. But the idea is that we know there's some boreholes at the power plant that go down maybe almost 2 kilometers, something like that. So we have some subsurface information there. I don't know how deep our subsurface data goes on the Reykjanes Peninsula. I doubt it probably goes much deeper than about 2 kilometers. So it would be great at some point is if we could put some money and resources into drilling a few very deep holes on the Reykjanes Peninsula in different places, maybe down as far as 4 or 5 kilometers if we can get that far, and then look at that subsurface data and get a more complete volcanic history here. Because our data, and I mentioned this in my interview, one of my questions to him was, hey, we can only go back about 3,000-4,000 years here, which isn't very far. We can only see 3 eruptive periods, so it'd be great to get more data if we can, but right now it seems in the short term unlikely. But do we have the ability to? Yeah, so it'd be great if we could get that. From Bart Rivers, how long will the magma inflow continue, guesstimate, and will it trigger eruptions in other regions in Iceland? No idea. We have magma moving up from a deeper source into this shallow body underneath the power plant region. It looks like it's been fairly steady, possibly since late 2020, maybe earlier than that. And it can these things can sustain themselves for long periods of time if you look at Hawaii and other sorts of places. Will it trigger eruptions in other regions in Iceland? I would say right now there's no evidence to suggest that we're going to see other volcanic systems outside the Reykjanes Peninsula becoming active because of what's going on here. Now, that being said, we have other volcanoes that have shown signs of unrest that are just have their own different plumbing systems. So could we have more than one eruption in Iceland at more or less the same time? Absolutely, because we have, I don't know how many there are, like 30 or more volcanoes there. So very possible. Possible but not likely is probably a good way to put it. T. Jenkins, if we send in random road cut pictures in our area, would you be willing to talk about the geology of those road cuts? Oh boy, that would be fun. I'm pretty inundated right now with emails and such that I don't want to open up that can of worms. I've had plenty of people recommend road cuts to me, some of which I probably can get to because they're reasonably close, but many of which are like, 2 days drive away or more. So I would say I would like to see, the whole point of the random road cuts is that if the more you learn as viewers and individuals interested in this stuff, that you can hopefully start to apply those tools to your observations and you become empowered as a learner in geology as well. I do want to do at some point a video on how you can figure out the geology in your area. It doesn't always work well, but there's some resources that are available out there that some of you I know about, but most of you probably don't. And I want to do a video that kind of shows you sort of the the cheat code, if you will, or how can I figure out the geology or the rocks around my region without having a geologist come and tell me about them. So yeah, so I'm going to probably say don't send me random road cut pictures right now because I just can't handle the volume right now. But and even if you sent me a picture of a road cut, it doesn't replace being there, right? Like being there and me touching the rock and seeing the scale. One photo, I could probably infer some things off a photo, but obviously, the direct experience and the observations I make in the field would be more valuable. So, all right, looks like we have 6 more questions if you're still with me, team. Leslie Martin, I would like to have a better understanding of the center of the Earth's magma chamber. How much is understood since it's so deep? Is that chamber being replenished? Well, the center of the Earth is not a magma chamber. The core of the planet is an inner solid core of iron and nickel. So outside that is the outer core, which behaves like a liquid based on the way earthquakes behave when it passes through it. Also probably has iron and nickel and other dense elements, but it's not necessarily the source for magma supplies. Magma supplies vary by tectonic setting. At subduction zones, you generate magma by one mechanism. At divergent boundaries, you generate magmas by a completely different mechanism. And then there's things like Hawaii and hotspots, which Iceland has a role in that as well. In terms of how much we understand, no, we don't. I mean, the deeper you go into the planet, the more unknowns pop up and the less data we have. So we're trying to figure out what's happening thousands of kilometers into our planet when we can't go there, we can't access the data directly, and so it's a really tricky place to try to make observations and therefore conclusions. So from Dirk Behrens, could it be all those fissures are raised chronological and those moved away from the hotspot beneath Svartsengi due to the plate movement? So would you consider as one system? No, because I don't think they popped up. I'd have to look at the data, but I think this one erupts and this one erupts, and so there's not like a clear, if I'm reading you right, there's not a clear progression of eruptions from one fissure to the next one to the next one. So I don't think the plate boundary comes through the interior of the country, and so all of them are sitting, quote unquote, on or very close to the plate boundary. Cool days for me. Does Iceland have a history of a super volcano? No, not in the sense of what we call a super volcano today, like a Yellowstone or a Long Valley caldera or something like that. In terms of a super volcano is defined by, and I can't remember the number off the top of my head, the amount of volcanic material it puts into, that it emits, whether it's ash or lava. So it has some more explosive volcanoes for sure. And what we're seeing on the Reykjanes Peninsula, these are tiny volcanoes. I mean, the amount of lava we're seeing coming out of these is, in the world of volcanoes, very, very minor. But there are much more explosive ones in Iceland. There's ones that have put out a lot more material during an eruptive period, like the Laki eruption in 1783. But yeah, I don't think there's one that you truly would call a super volcano. From S. Foss, how does the college feel about the time you spend on your YouTube videos? Are they supportive? Yeah, good question. I don't think is the college collectively, like the administration, they know I have a YouTube channel, 100%. Are they supportive? Yes. They think if you're doing good things in the world, keep doing good things. They did grant me my sabbatical last semester to go out and make more videos with the intent of using some of those videos in my geology classes, which I've done. A lot of my online classes, they view videos and I have questions they answer, and that allows me to bring the field trip or the landform or the process to them. Is the college like financially supporting me doing this? No. Not at all. And I'm not asking for that. So I still, my real job, my real, I'm, supporting my family and medical insurance comes from working at the college, teaching classes with the students, and that now is going to always be my number one focus. But the YouTube channel, I see it as an extension of that. I mean, to me, teaching is teaching. And so the lines do get blurred a little bit for me when something cool happens in Iceland and I'm down in the classroom sharing it with students. And then I jump on my computer and share it with you people. Like, I don't see it as college time, my time kind of thing. Do they know how much I'm doing? Probably not. Do they know that I'm up here on a Sunday morning doing this? Probably not, but that's okay. So I don't know how they feel about it. I think they're supportive. I think the notoriety that I give the college through doing these, they probably appreciate it. But I don't feel like I'm, being neglected or that they should or could do more. When I wrote my first book on Southern Idaho geology, they gave me a sabbatical to work on that, which I super appreciated, so I could focus on that. So in general, I'm really happy with the college I work for. They're very supportive of every little project and idea I've had, including this YouTube channel. I've had nothing but support. Like, yeah, that's a great idea. You should do that. So, yeah, hopefully that answers that. Interesting. Okay, last two questions, team. Let's see. Tom Day, can you discuss the subplate under Iceland and how it works? The professor mentioned it, but no details. If he mentioned that in my interview, I must have missed that. So I need to go back and see that. I've read a paper or two about there could be a little, possibly a continental plate fragment that's underneath or attached to Iceland somehow that provides some of the different magma material we see further over to the east in central Iceland, because we have some volcanoes over there that erupt different material than what we're seeing on the Reykjanes Peninsula. We have volcanoes that erupt rhyolite, and there's obsidian in Iceland. And so there's a very different magma composition beneath some of these Icelandic volcanoes. And this idea of a little continental fragment plate potentially provides some of the elements or chemistry to make a very different magma composition. There's others who argue that no, that's not what's going on. It's just crystal fractionation of the magma that's actually creating these other magma types. So yeah, so if that's what you're referring to, then I'll have to see if he did mention that, because I didn't think he did, but I might have missed it. So, all right, and our final question, Rick Floyd, you're the lucky winner. Maybe Shawn could have a video where he answers questions from the group. Like right now? I don't know. I have no idea what that's asking. The group, like my viewers? Answers questions from the group. Maybe he's referring to something else, though. I don't know. Someone just said maybe I'm getting pranked again. That's a great idea, Rick. We should have a video where I ask the group, the viewers, to ask me questions and I answer them. Brilliant. There you go. Woohoo! Fun stuff. Good stuff here, team. We did it. Nailed it. Over and done with. So, hopefully that was helpful. I again apologize we weren't able to get the drone flight put together, but Nature Eye is on it, and I'm sure they'll get back to me when we can make that possible. Would be great if we could have that drone flight coincide with the next eruptive event and being able to see some of the things from the air. I think we've seen the value in having that. Yeah. Susan says, I think he meant live questions. Aren't these live questions? I don't know. Maybe I didn't get enough sleep last night. I'm just kind of catching up on the chat here. Yeah, I have no idea what's going on. There's a lot of different conversations on the chat that I feel like I don't know what the context is. So there's some joke going on. Something about dancing on the tables. Yeah, I'm oblivious. There was limited time today to get to live stream because, yeah. Yeah, so didn't get to do as much. Sometimes in some of the past live streams we've done like 2+ hours. But I do need to get to a family obligation. Oh, like a big Zoom is what Susan's saying. Um, yeah, I don't know. I would not want to be the person that's handling a Zoom with like, more than maybe 8 or so people. I don't know. Maybe he means a video answering the questions you can't get to. Oh, I see. Yeah, like there's probably more questions that came in. I did tell Amanda Joe just probably 3 pages, 30 or so questions would probably be enough for today. Um, yeah. Yeah, I mean, there's all sorts of different ways to do this. I'm trying my best, so I hope that I'm able to get to most of your questions. It's great being the point of contact for so many of you, but I would also, like consider look around your area and see, do you have any other geologic expertise folks in your community? Maybe you have a college nearby and they could answer that question about that road cut that you want to send to me. You never know. There's probably some other options there too, but as always, I definitely appreciate being thought of as a quote unquote expert, even though I don't consider myself an expert. I consider myself knowledgeable in a few very narrow lanes and a learner in a lot of other sort of arenas. So good stuff here, team. Well, I think we did well. If Susan and Amanda Joe can tell me if I screwed anything up or if anything went off the rails, I'll of course go through all the live chat stuff later. This will get posted and will be up and ready to go. Moving forward here, team, what can we expect this next week? I'll get some of those Bryce Canyon videos out. There's a couple of those I need to put together and get those out. We'll probably there's a good chance we'll see each other very soon when something eruptive happens in Iceland, so look for that. I'll try to get some of these other ideas put together too. I've just got a lot of different thoughts going on. But for sure I don't know if we'll do another live stream this week, but for sure next Sunday, please join me when we have a live stream with Nick Zentner from Central Washington University, a very prolific geologist who puts out a lot of great publicly accessible content on YouTube and on other platforms. So that should be awesome. Thanks to all who have been supporting the channel, those who've provided support for me putting this together and also for Amanda Joe. Thanks to Susan and Amanda Joe for being the great moderators today. Much appreciated. Hope you are all well and hope you continue to be well, and we will see you next time. Thanks again for joining me. Appreciate it, team.